gear oil pump. So this is the gear oil pump setup. So what we are going to do is we are just going to use oil instead of liquid. So how it works, let's see. So this is the setup of the gear oil pump, and this is called the main tank, or you can also call this a sump. Okay, so what happens here is, so see here, they gave the specification of gear oil pump, power how much, head how much, and all they gave the specifications. So this is the main tank. Inside this tank, the tank will be filled with a SAE oil. Okay, so initially the tank will be consisting of oil, then this is called the collecting tank. So here we will be having a collecting tank where we can collect the oil and can use for calculation purpose. And next thing is, this is called the motor, and this is the main switch, and this is the reading for noting down the time taken. So in the collecting tank, what kind of oil will be collecting this? It's SAE 40. Just here, grade SAE 40, 882 kg per meter cube. So this is the tank, collecting tank capacity. Initially we will be having the suction line. Okay, so this is the main tank. This is the main tank. From this tank we will be collecting the oil. So actually what happens? Your gear oil pump based. So the oil will be collected from. I mean, this is the main tank, right? So with the help of suction, actually what happens is, here we will be having two gears. The gear which we use is a spur gear. Okay, so one will be rotating in clockwise and another one will be rotating anti-clockwise. So in between them, in between the clip, there will be interference. Okay, so what happens is, both the rotating gears develop a liquid seal in between. Because of these things, what happens is, the oil is pumped from the inlet with the help of suction. So oil is pumped from the inlet with the help of this rotation of this gear. So due to this rotation only, the oil is sucking. And this is the suction line. Here we will be having a vacuum gauge. See here we will be having a vacuum gauge. The vacuum gauge won't deflect. We will be having a constant value. So okay, when we start running the experiment, we can note down the values. And here we will be having impeller blades. Inside this casing, we will be having two gears, spur gears, and this is the best example for the positive displacement pump. And this line is called as the discharge line or discharge pipe. Okay, so here we will be having a pressure gauge, and the function controlling of pressure gauge is done with the help of the gate valve. So here is the gate valve. By rotating clockwise or anti-clockwise, we can control the pressure gauge. Okay, once we start the experiment, what happens is, once we set the pressure means, the oil will be keep on collecting in this tank. Initially we will be having the drain. Okay, if the valve is open means the oil will be sent to the main tank itself. If we close that valve means, what happens, the oil will start collecting in this tank. Same procedure, we just going to note down the height. Okay, once we close the valve, see here, once we close the valve, for a height of 10 centimeter, we will be noting down the time taken for the oil for collecting in this collecting tank. So this is the main. You have to switch on this main, and then you have to press this switch so that pump start working. The reason for telling now is because once the pump is working, the sound will be very much louder. So whatever I explain won't reach you guys. So that's why I just tell how the procedure is. Next thing is, we know very well, once the motor start running means the oil getting come from the suction line. So this is the suction line, and here is the vacuum gauge. So the oil will be sucked up and it will be coming to this pipeline. This line is called a suction line or suction pipe. This is the vacuum gauge. Here we can note down the reading, and here is the pressure gauge. We can turn down this gate valve for increase the pressure. Okay, we can increase the pressure slightly for different readings, but vacuum gauge reading will be constant. And then the oil will be coming back to this tank. Okay, the thing is, now the valve is open. See here, now the valve is completely open. So now the valve is completely open. If I close the valve, like this, clockwise, in clockwise means the valve is open, and it closed. Anti-clockwise means open. Okay, now I am closed the valve, so automatically what happens, the oil will be started collecting from this collecting tank. So it will be gradually rising up. For 10 centimeter, height of 10 centimeter, we need to note down the time taken with help of the stopwatch. And next thing is, here we will be having energy meter. See here we will be having energy meter. So this is called energy meter. For fire revolution, we have to note down the time taken. Okay, so now it's everything is in off setup. So once we on means, the same procedure we have to proceed. So this is the main. You have to switch on the switch. And next thing is, here we will be having a switch. So you have to turn it down so that the motor start running. See, now the motor is working. the pressure gauge is set to 0. Now the pressure gauge is set to 0. See here, and we will be having the vacuum. Just note on the vacuum gauge reading. So here will be vacuum gauge reading. So now what happens is the oil is sucked in to the suction line. It will be coming to the delivery line. See here, this is called the collecting tank. It will be collected up here, and oil what we use is SA oil. Now the drain pipe is open, no, so automatically all the oil will be sent back to the main tank itself. All the oil will be sent back to the main tank itself. If we increase the pressure, pressure of the pressure gauge.
Start.
Now I already set the reading for 0.2. If we turn in clockwise direction, just note on the dial gauge. It will be increasing 0.2, 0.2 itself. See, the needle is moving up. Just note down, needle is moving up. So 0.2 I have set the pressure gauge and note down the vacuum gauge reading. Okay, and simultaneously you have to note down the energy meter reading also. With the help of the stopwatch for fire revolution. See here, the energy meter is working right. With the help of the stopwatch, you have to note down for fire revolution how much time taken. Now what you are going to do is, now the valve is completely open. So automatically all the oil will be sent to the main tank itself. If you try to open it up, if you try to close it, okay, if you try to close it, see here what happens. Oil is started rising up. See here, the oil is moving up, and you have to note down for 10 centimeter. See here, for 10 centimeter height, how much? For 10 centimeter height, how much time is taken? You have to note it down. Now just open the valve, so that all the oil will be dropping down. It will be going back to the main tank itself. Whatever you did, the same procedure you have to repeat for remaining 4 or 5 readings.
Start.
For closing this experiment, what you have to do is, you have to reduce the pressure to 0. You have to bring back the pressure to 0. Before that, you should not switch off the motor. Bring the pressure to 0. So after bringing the pressure to 0, now we can switch off the motor. See here, switch off the motor, and then you have to off the main. Now we have experimented how to do the experiment of a gear oil pump. Now I will tell how to do the calculation. So this is the tabular column part, and here we will be having a specification. Just see, constant speed of the pump, area of the collecting tank, energy meter constant, how much value we have to note down, and distance between the center of the vacuum gauge and pressure gauge, how much distance is there. Lubricating oil use, what lubricating oil we use, SAE 40 as I mentioned there. So this is the tabular column. Here we have to note the pressure gauge value, here vacuum gauge value. Vacuum gauge value is constant 160 as I said before. Total head we need to calculate with the help of the formula. This is the time taken for the rise of the oil for height of 10 centimeter. Actual discharge we need to calculate with the help of the formula. This is the time taken from the energy meter. And this is the input power, output power, efficiency of the pump. All these things we need to calculate with the help of the formulas. All the formulas we have clearly given in the observation manual. Just see here, we need to use all these formulas. Just see here, have a look at it. The total head, actual discharge, input power, output power, efficiency of the gear oil pump, all the formulas are there. Just substitute the values and calculate the remaining things. And in case if you have any doubts, you can ask me. And graph we need to plot. Okay, so x-axis will be, see here, x-axis will be the head. Okay, so head will be x-axis and y-axis will be output power, efficiency of the pump, and actual discharge. So finally you will be getting a graph like this. So once you plot it means you will be getting a graph like this. And whatever values you are getting, finally we have determined that efficiency of the gear oil pump. So approximately it will be coming by 11.6%. So finally we have determined the efficiency of the gear oil pump, and speed is very constant. That is, the characteristics of the gear oil pump is constant. Okay, you have to remember this. And interference, just note down whatever values you are getting, interrupt and write interference. And I hope so it's very clear to do the calculation.
Start.
So we have seen how the working of the gear oil pump and how we have to